Welcome back to G-Fun Facts Online. Today, we are moving beyond the hype cycles of the latest chatbots or smartphone releases to talk about the physical reality of the internet. If you are listening to this in early 2026, you might have noticed that the conversation around artificial intelligence has shifted. It is no longer just about code, algorithms, or parameters. It is about concrete, copper, uranium, and water. We are witnessing the construction of the most complex machine ever built by human hands. It is a machine that spans continents, consumes rivers, and splits the atom. The industry calls it the Stargate Grid. To understand where we are today, we have to look back at the wall we hit in late 2024. This period is now referred to by energy historians as the Kilowatt Cliff. You see, for decades, data centers were just boring warehouses with air conditioning. They consumed a rounding error of the world's electricity, maybe 1 or 2%. But the generative AI boom changed the fundamental physics of computing. A standard rack of servers used to sip about 10 kilowatts of power. But when companies like OpenAI, Google, and Amazon started stacking NVIDIA H100 and Blackwell chips to train trillion-parameter models, that power density exploded. Suddenly, a single rack was pulling 100 kilowatts or more. When you cluster thousands of these racks together, you stop being a customer of the power grid, and you start becoming a threat to it. By 2025, the International Energy Agency confirmed the worst fears of Silicon Valley. Data center consumption was on track to double, reaching 1,000 terawatt-hours by 2030. To put that in perspective, that is roughly the entire electricity consumption of Japan. The tech giants had the chips, they had the data, and they had the money, but they did not have the electricity. And crucially, they couldn't rely on the old strategy of just buying green energy credits. Solar and wind are intermittent. If the wind stops blowing in West Texas, you cannot just pause a massive AI training run without suffering efficiency losses. AI needs 99.999% uptime. It is a relentless beast that demands a steady heartbeat of electrons. This crisis birthed the Stargate Initiative, originally just a code name for a supercomputer proposed by Microsoft and OpenAI. Stargate became the banner for the entire industry's pivot toward nuclear power. The turning point, the moment the world really paid attention, was the nuclear autumn of 2024. In a move that would have been unthinkable just a few years prior, Microsoft signed a 20-year deal to restart Unit 1 at 3 Mile Island. Yes, the site of America's most infamous nuclear accident. The symbolism was impossible to ignore. Big tech was so desperate for power that they were willing to resurrect the dead to get it. Amazon Web Services followed suit, purchasing a campus connected directly to the Susquehanna steam station, effectively buying the nuclear output behind the meter and bypassing the public grid entirely. But buying old plants was just the opening move. The real innovation of the Stargate Grid is the architecture of the new Gigawatt Campuses being built right now in 2026. These are not data centers as we used to know them. A Stargate-class facility is a fortress. It has three main components: the core, which houses millions of GPUs, the shield, which is a massive thermal management system, and the heart, which is the on-site power generation. And that heart is almost always a small modular reactor, or SMR. This is where the engineering gets fascinating. Unlike the cathedral-sized cooling towers of the 20th century, SMRs are factory-built, ship-portable nuclear batteries. Companies like X-Energy and TerraPower design these to be walk-away safe. That means physics, not human operators, shuts them down in an emergency. In the Stargate architecture, these reactors are deployed in 6-packs or 12-packs, just meters away from the server halls. This proximity is vital. By generating power right where it is consumed, tech companies avoid the transmission queue. In the United States, waiting for permission to connect a new power plant to the national grid can take a decade. By building these islanded microgrids, big tech effectively seceded from the public utility system. This shift has completely redrawn the map of the technology sector. Silicon Valley is too dense, too regulated, and too seismically active for this kind of heavy industry. The new capital of AI is the Energy Belt. We are seeing a massive revival in the Pennsylvania-Ohio corridor. The Rust Belt is becoming the Brain Belt. Why? Because they have fresh water for cooling, they have existing nuclear sites with grid interconnects, and they have industrial zoning. We are seeing decommissioned coal plants being retrofitted, not to burn coal but to serve as pre-wired sites for these nuclear data centers. Down south, the Texas Triangle has become another massive node. The Texas Gigacluster near Abilene is utilizing a hybrid approach. They use massive solar arrays to handle cheap inference tasks during the day, while gas turbines and planned SMRs handle the relentless baseload of model training at night. And in the Pacific Northwest, the hydro capacity is maxed out, so we are seeing a hydronuclear hybrid model emerging, pairing dams with reactors. However, generating the power is only half the battle. The other half is getting rid of the heat. This is the engineering nightmare that keeps thermal architects awake at night. A 5-gigawatt data center produces 5 gigawatts of heat. That is enough thermal energy to heat a medium-sized city in the dead of winter. You cannot just pause air over these chips anymore. The Stargate facilities have abandoned air cooling entirely. They now use direct-to-chip liquid cooling and immersion cooling, where the server blades are literally submerged in baths of non-conductive fluid. This produces massive amounts of hot water. In Nordic countries, they pipe this into district heating systems. But in the US, it mostly goes into evaporation towers, consuming millions of gallons of water a day. This has sparked legal battles with local agricultural communities, a conflict that is defining the politics of 2026. Speaking of politics, we cannot ignore the geopolitical arms race driving this. The Stargate Grid is a national security asset. The US government realized that the nation with the largest training cluster controls the 21st century. This is why we saw the passage of the AI Permitting Reform Act of 2025. It was a bipartisan deal. Republicans got nuclear deregulation, and Democrats got safety oversight on the AI models. This legislation allowed for the fast-tracking of nuclear licensing, which is the only reason these facilities are coming online so quickly. It is a strategy designed to counter China. While China builds reactors faster than anyone, they are choked off from the most advanced GPU supplies by US export controls. The US strategy is a pincer movement. Starve them of chips while outbuilding them on power infrastructure. But this has caused panic in other nations. The UAE and France are rushing to build their own sovereign AI clouds, creating a fractured, multipolar digital world. The economics of this are staggering. A single campus can cost $30 billion. The full build-out is estimated at $2 trillion by 2030. This price tag has created an insurmountable moat around the industry. Startups cannot afford to build Stargates. The AI landscape has solidified into an oligopoly of the hyperscalers: Microsoft, Amazon, Google, Meta, and state-backed entities. The era of democratized AI infrastructure is effectively over. The future belongs to those who own the gigawatts. Now, there is an environmental paradox here that we need to address. On one hand, this is the largest deployment of carbon-free energy in history. By mass-producing SMRs, big tech is lowering the cost of nuclear power for everyone, potentially helping to decarbonize the entire grid. On the other hand, the embodied carbon of building these massive concrete structures is immense, and the sheer addition of 100 gigawatts of new load cancels out years of efficiency gains elsewhere. Critics argue we are burning pristine nuclear energy just to generate deepfake videos and chatbots. Proponents argue that the AGI we create will solve material science problems that ultimately pay off that carbon debt. So, where do we go from here? As we look toward the 2030s, the grid is evolving again. We are looking beyond fission. Microsoft's bet on Helion Energy suggests a future where fusion power might replace uranium, removing the fuel constraint entirely. We are also seeing a push toward optical computing, using photons instead of electrons, which could drastically reduce the heat output. But for now, we are living in the era of the Stargate. We have effectively decided to wrap the planet in a layer of silicon and copper, fed by the splitting of the atom. In 2024, the question was whether AI was smart enough. In 2026, the question is whether we are strong enough to power it. The Stargate Grid is our answer. It is a gamble of colossal proportions, a bet that the intelligence we create will be worth the energy we consume to birth it. The turbines are spinning, the cooling pumps are roaring, the training has begun. Thanks for listening to this deep dive on G Fun Facts Online.